So hey guys, how are you? Have you checked the previous lecture on the matrices? It's amazing. So I hope you like that. So after we just completed the transpose of the matrices. We just completed the transpose of the matrices, and just we going to cover some of the important and the most interesting topics in the matrices. So we going to cover the special types of matrices. So what do you mean by a special types of matrices? So what do you mean by what do you mean by the special types of matrices? So a matrix is called as a symmetric matrix. So when it is called as a symmetric matrix, if it is equal to its transpose, like we have example out there. If the diagonal is 0 0 0, if it is equal to transpose, like if we change also the transpose is equal to this, and we just simply call it is also symmetric matrices, like we have over here. So we have 1 over there and we have a 0 over there, and that's it, bro. It's just a kind of a matrix is a symmetric matrix if it equal to its transpose, if it is equal to transpose. So there is nothing out there. And then after that we have a called as a linear transformation. So what is linear transformation? So it can be thought as a functions. It can be thought as a functions where a function takes some values and map it into a different values. It takes some values and map it in a different values. Like we have example in our childhood, like if we have a f is fx square, if we put the value x, and then it will become 4. It's just a common example out there. So what we are doing with these linear transformations in the matrices? So it just transforms the vectors form from n-dimensional space to the m-dimensional space. So it's just transforming the n-dimensional space to the m-dimensional space. Like we have a m into n matrices, and we have a n into one vector. So it's just transforming these two, and then we getting our m into one resulting vector. Like this is matrices, bro. Just I'll give you example. This is matrices and this is vector. So we have a transformation over there. So the first row of this, and we have a connection with the vector first column. Vector first column. The first number, these first and these first will become these are transforming. And then we have a m into one resulting vector. That's it. There is nothing special about there. Just a transformation of their values from n-dimensional space to the m-dimensional space. That's it. And then there are some conditions need to be satisfied in order to have a linear transformation. Like we have a transpose of x plus y. We have a transpose of x is equal to the transpose of x plus transpose of y. And then we have like if the transpose is outside, and then we get a transpose x. I hope you're getting, like if we have a transpose is outside, and then we're going to get in the it insides. That's it, bro. That's it. So after that we have some of the main topic in our matrices. Like we have many number of 12 to 13 kinds of matrices out there. We have 12 to 13 matrices out there. So we're going to cover each and every matrices in detail. I hope you love it. Like I just worked so hard to make these notes. So I hope you subscribe this channel and share with your friends. So I'm just making these videos for free, absolutely free, because I know some students who don't have the money to learn, which is structured in a way that it will get a job. So if you give 150% to this course, and I'm sure that you will get a decent job. You can earn a minimum of lakhs of, maybe more than a college placement in our tier 3 colleges. So I hope you love these videos. So after that we're going to cover, so just leave it there. So after that we're going to cover a row matrices. So what is row matrices? So I just zoom some. Yes, it's good. So what is row matrices? Like a matrices having only one row. I hope you're getting, like, so a matrix is having only one row, then we simply called it as a row matrices. Like, so for example, we have 1 2 3 4 etc, and then we have a b c d e f g and many more. We can have any kind of stuff, and this is called as a row matrices. The rows are here, right? So as I said, the rows are in a horizontal direction, so this is called as a row matrices. And then we have a column matrices. As I said, rows will be here and the columns will be downside. So just having a matrices having only one column. If a matrix is having only one column, then we simply call it as a column matrices. Like we have a 1 2 3 4, and then we simply have a columns out there, and just we have a column there, and we simply called it as a column matrices. And then we have a something known as zero or null matrices. So by the word you can understand zero or null. Null means what? Null means what? There is nothing else. There is nothing there, bro. There is nothing there in that matrices. In that matrices. So all the columns and the rows are zero. So zero means what? There is no nothing about in the there is no nothing in the matrices, right? So the all the columns and the rows are zero. So here we taken an example like the A matrices like into 3 into 3 dimensions, and we have all the zeros out there, and this is called as a null or zero matrices. Why? Because there is no values in that matrices, so then we simply call it as a null matrices or the zero matrices. So after that we're going to cover something known as horizontal matrices. So what do you mean by like a horizontal matrices? So it's just a kind of rectangle matrices. It's just a kind of rectangle. So it is rectangle, right? Yes or no? Yes. So it is a rectangle matrices. So it's just a kind of rectangle matrices. Like the number of columns is greater than the number of rows. So we have two rows here, but we have a 1 2 3 4 columns here. So we have two rows and we have a 4 columns. Means like the number of columns are greater than the number of rows. Yes. So then we call as a horizontal or a rectangle. So we don't use the rectangle, just I am giving the example. We use the horizontal matrices. Like by the diagram you can understand, bro. By the understanding that it is horizontally divided, it is horizontally. So after that we have something known as a singleton matrices. So what do you mean by a singleton? If they're having only one element, having the only one element in the matrices, then we simply call it as a singleton matrices. Like we have example like 2 5 18. It's not a 1 8, it's just 18, bro. It's not a 1 8 1,8, it's just 18. It's my favorite number, 18. I love this number, I don't know why. Yes. So it's out of topic, just come to her. So after we have a in the sixth like a vertical matrices, as we simply discussed in a horizontal matrices, and that is as the same as vertical matrices. So what is the specialty of this vertical matrices? So if we simply look at this, like if the number of columns is greater than the number of rows, here we have the opposite kind of thing. Like the number of rows is greater than the number of columns. The number of rows the greater than the number of columns. Like we have a 4 rows. We have a 4 rows and the 2 columns. And we have a 4 rows and we have a 2 columns here. So the 4 into 2 dimensions. So this is called as a vertical matrices. So we're going to cover all these in our Python video. Like we are going to have some of the beautiful concepts out there. We just do simply just in a one line of code with the output, not doing these complex and plus into minus etc. We just type that and the answer will come automatically. It just you feel like this much easy, then why we are doing in our hands. So you're going to feel that in our few lectures. You don't worry, you have to be like a kind of thing. So like that. So after that we have a something called as a square matrices. So what do you mean by a square? So what do you mean by the number of dimensions must be equal? The number of dimensions must be equal. Here the 2 into 2, and we have a 3 into 3. So the number of rows is equal to the number of columns, as I mentioned. Like the number of rows is equal to the number of columns. Then we simply call it as a square matrices. Like we have a dimensions equal, bro. We have a square means like the square means like this. So all the length, the length of A, the length of B, the length of C, and the length of D, all are equal, bro. All are equal. So we just here the dimensions also must be same. Like if there are two elements here, and then we should also have a two elements out there. So there is nothing much explanation out there. It's just a simple kind of thing, just a basic mathematics. So after that, we're going to have a diagonal matrices. So what do you mean by a diagonal matrices? Like having a diagonal, like, so I will give an example, then you will going to understand. Like if the vector, if the matrices have a, so if the A matrix is like 1 1 0 0 0 2 0 and 0 0 3. So I just take an example, like I just taken 0 because you will get a good clarity like what is the diagonal. So this center part is called as a diagonal. So in a lecture of transpose, as I said, that it just flips its diagonal. So what is diagonal? This part is called as diagonal. So the diagonal matrices is like we simply take out these diagonals, the diagonal, and then this is called as a diagonal matrices. I hope you understanding this. So I hope you follow this lecture. So after that, we're going to have something known as rectangular matrices. So where the number of rows not equal to the number of columns. So as I said in the examples of horizontal and the vertical matrices, like the rows are not equal to the columns. Like we have a in that example, we have a 2 into 4 matrices and the 4 into 2 matrices. Like these are two not are equal, like the number of rows are not equal to the number of columns, right? So just a kind of thing. So we have an example like n is not equal to m. So we have example, like if we have example like this, there are too sleepy today, but I have taken a new resolution to complete these lectures. So I have no excuse like for leaving that and having a sleep. So I was too sleepy, but I will finish whatever it happened. Just focus on this lecture. So like we have a 1 2 3 4 and 5 6 7 8, and then we have a matrices out there. It is a 2 into 4, means the columns and the rows are not equal here. The rows are 2 and the columns are 4, means it is not equal. Then we simply call it as a rectangle matrices. I hope you understand it. Like, so it's nothing like there is not a this is not a like a rocket science you can't understand. It's just simple mathematics, bro, and I'm making it even more simple. Like, so after that we're going to have something known as scalar matrices. So what is scalar matrices? The principal diagonal. Oh my god. So what is the scalar matrices? So what is the scalar matrices? So the principal diagonals are same. If these are same, then we simply call as a scalar matrices. Like we have taken a root 5 example because we are taking 1 2 3 as a routine example. So just we have to take a different one. So I just take a root 5 out there. So why it root 5? It's just a number, bro. I have taken it just a kind of new example out there. So these are all equal, bro. These are all equal. So the principal diagonals are same here. So then we call it as a scalar matrices. Then we simply call it as a scalar matrices. So after that we have something known as the triangle matrices. So what do you mean by a triangle matrices? So what do you mean by triangle matrices? Like if the element above or below the principal diagonal are zero, if the elements are above or below the principle of the diagonal at zero, then we simply call it as a triangle matrices. Like I'll give you an example. Like we have given a good example over here. So the below the principal diagonal, these are all zeros. Then I have given a simple diagram. Like I have given a simple diagram over there. I have given a simple diagram here. So I just dotted the line, like it's forming a triangle. Can you see it? It's forming a triangle. It is a upper triangle matrices. It is a upper triangle matrices. And then we have a zeros on the top of that, and we have a formation of triangle out there, and then we simply call it as a lower triangle matrices. Lower triangle matrices. So this is the last type of the matrices which I'm going to cover, like the matrices. So what do you mean by asymmetric matrices? So like if we transpose A in and the answer, if it has to be transposed, right? But the answer is also A, means the values are same, right? Are you understanding? Like, so I'll give you example. Like if the A transpose A is equal to A, then the matrix is called as symmetric. Symmetric means what? It just means same, just means same. Like we have a transpose over there, we have a 2 2 2 2. If we apply the A transpose and just it flips, the 2 will come here and the 2 will come here. So after that, so what is the answer? The same is answer. So forget that. So it is 2. So what is the answer? The same is answer. So if it comes like this, then it is called as a symmetric matrices. Symmetric matrices. So for being a symmetric, you have to have a square matrices. We can't do in a rectangle, we can't do in a horizontal and a vertical matrices. We must have a square matrices. So like we may have a 2 into 2 and 3 into 3, 4 into 4 and 5 into 5 also. 5 into 5 dimensions also matrices. Even we have in our problem set like 600 into 600 matrices also, bro. So I cannot draw those matrices like 600 here. So in our computer, with the help of the amazing libraries, we just simply in a snap. So I hope you so after that, in a next lecture, we're going to cover some of the most important topics like a determinant, how we find that determinant, and we have some kind of properties out there, and we have something known as the rule of Saros. The rule of Saros is just a kind of fancy word, like what do you mean by Saros? So rule of Saros. And then we're going to cover the cofactor, minor, adjugate, etc. So we have a lengthy lecture. The next lecture is going to be one of the most important topic in the machine learning. So I hope you enjoy this. So until then, bye bye. So see you in the next lecture. So until then, just revise what I have said. If you like this lecture, so please share with your friends and watch it fully, bro. So I have seen these, most of the videos are watching. If we have a 15 minutes of the video, the students are only watching 1 minute or even like a 2 minutes. That's it, bro. So I'm making the video at the noon of 1 a.m. So at the 1 a.m, bro. So please understand. So I'm giving 200% to this course, free course. Like I'm not charging a single paisa from you. So I hope you understanding. Yes. So you won't do, but some students are doing. So until then, bye bye. So we're going to cover some of the most amazing topics in our next lecture. So until then, bye bye.